Okay, so we are at part 2 of the exam review. Next topic is divisibility. Seeing if a number is divisible by a certain number. So if we take this number 233, we'll check for divisibility of 3 and 4. In other words, is 233 divisible by 3? And if you remember the rule, we can take each digit from the number, add it separately. So I'm just taking 233, I'm taking each place, the 2, the 3, the 3, adding them together, we get 8. If that sum is divisible by 3, then the whole number itself is divisible by 3. If not, we would say it's not divisible by 3. It's just a little trick that we can determine to see if a larger number is divisible by 3. So we can see, since 8 is not divisible by 3, therefore 233 is not divisible by 3. For 4, to see if a number is divisible by 4, you simply look at the last 2 digits. In this case, it's 33. If those last 2 digits are divisible by 4, then the whole number itself is divisible by 4. It's got to be divisible perfectly. So 8 fourths fit in 33, because 8 times 4 is 32. But because we have a remainder, we would say that 233 is not divisible by 4. That's 2 ways to check 3 and 4. Other numbers are a little bit easier that we've talked about. A number is divisible by 2 if it's even. A number is divisible by 5 if it ends in 5 or 0, like 5, 10, 15, 20, 25, so on. Let's check 522 using the same methods for 3 and 4. Okay, 5 plus 2 plus 2, taking each digit, adding them together, that creates 9. Now 9 is divisible by 3, so therefore we would say yes, 522 is divisible by 3. If we were to check it for 4, these last 2 digits, 22, are not divisible by 4. Divisible by 4 would also mean it had to be a multiple of 4, right? So it'd be 4, 8, 12, 16, 20, 24, and so on. You could try these excuse me, on your own, and check to see if they're divisible by 3 or 4, and then pause if you like. Okay, if you check 6,210, if you add up each digit, 6 plus 2 plus 1 plus 0, you get 9. So we'd say yes, divisible by 3. But for 4, again, the last 2 digits must be divisible by 4. 10 is not divisible by 4. So we would say 4, no. We could check this number, 324, same method. To see if it's divisible by 3, add up each place. 3 plus 2 plus 4, that'll get us 9. So yes, it is divisible by 3. And the last 2 digits, 24, that is also divisible by 4. It's a multiple of 4, so therefore it also is divisible by 4. Okay, if you're not sure of the other rules of divisibility, make sure you look at your study guide, and you'll see some rules on that as well. Factors is another topic. Factor just means something times something to equal the product. So factors of 20 are 10 and 2, 20 times 1, 5 times 4. Here I'm listing them as factor pairs, or you list them in sequence, 1, 2, 4, 5, 10, 20. Okay, that's all it is, factors of a number. You can go ahead and try to find factors of 24. Pause the video if you want time to do it on your own. Okay, if you got them, you should have had them like this. Either way you list them is fine. Just look at what the test question is asking. If they want them in ascending order, that means least to greatest. Or if they want them, the exam wants it in factor pairs, and so on. Okay. That should get us all the factors of 24. We can check the divisibility rules too to make sure we have them all. As far as it's an even number, so 2 will certainly be a factor, and so on. Prime and composite numbers. Okay, a prime number is any number that only has 2 factors. Okay, the only two factors of a prime number will be the number itself and 1. So there'll be other prime factors here, but I'll just stop there. So if we take 13 as an example, 13 times 1 is 13, but there are no other factors of 13. That's the definition of prime, only two factors. Composite is any number with more than two factors. So you could just think of your multiplication facts and so on. They go on for a long time. But if we take 4 as an example, any number times 1 is always going to be the factors, right? But also with 4, 2 times 2 is a factor. Once you can think of another factor pair, suddenly that number is composite. It's no longer prime, or it is not a prime number. GCF, or sometimes called HCF, greatest common factor, highest common factor. It's just listing factors of two numbers, like we just did, and then finding the greatest one, the largest one between the two. Okay, so you can list the factors of 12, then you list the factors of 18. No, I forgot 2. And you circle the largest one. So you would say that the greatest common factor between 12 and 18 is 6. If you want to try this on your own to find the greatest common factor of 30 and 36, go ahead and pause it. Okay. You would have found 6. I'm going to skip listing them out, but if you list out all the factors of 30 and 36, 6 is the greatest common factor. Okay, equivalent fractions. If we're looking at 2/3, we can make an equivalent fraction for that by multiplying it by any number, as long as it's the same number top and bottom. So in other words, 2/3 multiplied by 2/2, well, that's 4/6. So because I'm multiplying the top, the numerator, and the denominator by the same number, which looks like a fraction 2/2, I get 4/6. I can then multiply this 4/6 if I want by another 2/2, or if I want to do 3/3, anything over anything, as long as it's the same anything, you'll be fine. 8/12. So what we're looking at here is 2/3 is equivalent to 4/6 is equivalent to 8/12. Okay. The other thing you'll see with equivalent fractions, you want to find the missing part. So let's take the same ones. If we have 2/3 equals some number over 12, we want to find what that numerator is, okay? And we have our do-do rule. If you're given both denominators from 3 to 12, that's timesing 4, okay? So therefore, you have to times the top by 4 to find the missing digit, missing numerator, okay? And we see, like before, it's 8/12. We found that before by just multiplying top and bottom by the same number, which is kind of like this thing, right, that we just did. You're going to try this one on your own. Go ahead and pause. Okay, same deal. We're given both denominators. And from 9 to 36, it's increasing, and it's increasing by 4 times. 4 times 4. Therefore, we have to multiply this numerator up top by 4 to get 20. So we would say 5/9 is equivalent to 20/36. Simplifying fractions. The slide we did a couple slides ago of GCF, finding the greatest common factor. This is why we do it, okay? When we find the greatest common factor of two numbers, in this case in numerator and denominator, we can then divide by that common factor to simplify the fraction. Okay, another word you'll hear used is reduced to lowest terms. They are synonyms. If you hear simplified or reduced to lowest terms, it's going to mean the same thing. That's what we're doing right now. List out all the factors of the number, and we see 4 is the greatest one, and we divide that fraction by the GCF, or the greatest common factor. 16 divided by 4 is 4, 20 divided by 4 is 5. Now we're at the most simplified fraction. If you didn't find the greatest common factor and just a factor, that can still get you an equivalent fraction, but not the most simplest, meaning it's still going to have perhaps a factor to divide by. So you can divide the top and bottom by 2, still get an equivalent fraction. Now we're 8/10, but 8/10 is 9 simplified. It still has another factor of 2. So you can divide the top and bottom by 2 to get it most simplified form. Okay, 4 and 5, 4/5. There is no factor of 4. There's also a factor of 5 other than 1. Once you have that fact, you know you're in the simplified form. You can try this on your own. 24/30. You can pause if you want. Okay, here if you found it, you would find that 6 is the GCF. 24 and 30, when you divide by both, you would get 4/5. Fraction of quantity, in other words, 2/3 of 12, a fraction of a number, okay? We can change that of sign to mean multiply. We can put that whole number over top of a 1 to look like it's a fraction times a fraction. It makes for nice and simple and clean. Then we just multiply num times num. 2 times 12 is 24. 3 times 1 is 3. We just treat that fraction bar like a division sign, which it really is. 24 divided by 3 is 8. Okay. You want to try it on your own, you could try 2/5 of 15. Okay, if you did it with the same steps we did the previous one, change that of to a times, put that whole number over top of 1, and then do straight multiplication of your fractions, and then use that fraction bar like a division sign. You should have got 6 as your answer. 2/5 of 15 equals 6. Almost done. Comparing fractions, meaning which one is greater? Is 2/3 greater than, less than, or equal to 3/5? That's what will go in the box. It's really hard to compare them if they have denominators that are not the same. You could find the same denominator by listing the multiples of each denominator, and we'll create equivalent fractions with this new denominator, and then we'll be able to compare them much easily. So I'm just listing the multiples of each denominator. I'm looking to 3, to 5, okay. And I see once I have one in common, I can stop. I can see that 15 is the least common denominator. Then I turn each original fraction into its equivalent form with 15 as the denominator. Same thing what we did with the equivalent fractions. We find the missing part. 3 to 15 is 5 times bigger, so therefore 2 times 5 is 10/15. Now we take 3/5, and we do the same thing. We want to make sure we have 15 as our common denominator. We look at the do-do rule, and we would see that 9 goes up here. So we see that 2/3 is the same as 10/15. 3/5 is the same as 9/15. Therefore, 2/3 is bigger, okay? Greater than, because 2/3 has a 10 as a numerator, 3/5 has a 9. Once their denominators are the same at 15, you can just see which numerator is greater. You can go ahead and try this on your own if you like. 2/3 or 5/7, which one's greater than, less than, or maybe they're equal to each other. Okay. You should have found 21 as the common denominator. Change each fraction to a denominator of 21, and then you compare numerators. Okay, so it's another close race here. 14 over 21 or 15 over 21? Well, 15 over 21 is bigger, and that's the one that represents 5/7, the original question. So we would say 5/7 is greater than 2/3, or 2/3 is less than 5/7, however you want to say it. Okay, our last topic. When you have a numerator that is larger than the denominator, you want to change it into a mixed number. You use that fraction bar as a division sign. It's like 15 divided by 4. How many 4s fit in 15? Well, you can count by 4s 3 times, with 3 left over out of the original 4. So your whole number becomes how many of your denominators can fit into your numerator, 3 of those 4s. Your new numerator becomes the remainder. There's still 3 left over from the 15, and your denominator stays the same. Okay. If you want to go the other way, if you're at 3 3/4, and you want to go to 15/4, so you're going from mixed number to improper fraction, we talked about you multiply 3 times 4, or denominator times the whole number, then you add the numerator. So 3 times 4 plus 3 is 15, and like before, denominator stays the same. So 3 3/4 is equivalent to 15/4. It's just one's a mixed number, the other is an improper fraction. If you want to try one on your own, you could try 17/7 and try to go back and forth. Okay, if you tried it, you should see the 2 7s go into 17 with 3 left over, because 2 times 7 is 14. 3 left over out of the original 7. Oopsie. Out of the original 7. Denominator stays the same. Okay. And the back and forth, so it's 2 3/7. The back and forth is 2 times 7 plus 3 would give us 17 again. We're back where we started. You can go back and forth like that. Okay, boys and girls, that's the end of our review. Good luck on the exam. I know you're going to do great. You've worked hard, studied hard. Try your best. And just remember, no matter what, no matter your score, no matter how you do, know that I love you no matter what. Okay, take care. Bye-bye.